Back in the day, maybe they still sell them, March used to make a ram air intake kit. It would hang below the bumper. Because of the 5-liter intake, it would hang on the passenger side. Right here, well, in 3D printing a version, there's the scoop. Let's see if we can hold this up. It's going to live under here. And be ducted through the inner fender. I've got a bunch of parts to hook onto that. That duct is too long, but that's how it comes. And inside, under the hood, there will be a cone filter housing, and that will be the upgrade for that little filter and little pipe there. That's 3.5 inch. We're going to keep it 6 inch until it gets the adapter. The adapter is going to go from that 6 inch to 5. And then from 5, we're going to slowly work our way to the throttle body for a kind of a funnel effect. I will keep updates as we go along here. It's kind of my first large 3D printing project. We'll see how it all works. So it's always in the details, trying to get this stuff to work right. So I've added all this aluminum here to make the corner of the bumper actually hopefully strong enough to hold the actual scoop. I'm sure there's going to be some pressure there, so we'll start with pretty light, and the scoop itself is pretty light. If it cracks or whatever, we'll just print another one. But we're going to end up with the 3 holes in the front and then some on that nasty area there. This is a thicker piece. And we'll see if it stays on or gets ripped off and I drive over it. All right, our cold air intake, ram air cold air intake canister. The internal canister is in. We have the fender well canister in. We're hooked up to our scoop. Our scoop is hanging out down there, doing business. So we're just about to install the connection pipes to go from the edelbock supercharger, just clearing the radiator and kind of, and inside there is where we're going to put our air filter cone. So the air filter cone goes on this adapter. Got a PCV inlet. There's the air filter. Here's my cold air intake tube with a methanol nozzle stuck in it already. It's pretty cool. Got a pretty old rubber adapter here that's going to get replaced, but so what I had, that pipe has a lot of snake to it, but it's 3.5 ending up at 5 inch. So we will stick it all in there and see how it works on the dyno, and then see how it works on the track. Should be good. Got that all to fit. Got some little foam gasket on there on the bolt-up flange. And what we got is a lot of filter area in there. So hopefully I have enough area around the filter so that it's not restricting it at all. And we'll see if making this car breathe through a 6-inch pipe and a 13.5 by 2.5 funnel, will that be a problem stationary over just an open pipe like that, which I have dynoed, because this car is speed density, it does not need a mass airflow sensor. And what if I take the pipe out at the track and just run open pipe at the track with the hood closed? I'd have to plug this off too so that it's not blowing all of this lovely fresh air in here. But we'll see. We'll see if I've made it big enough to not hurt stationary and then hopefully help mile per hour wise. I mean, I just had a cone filter hanging out in the engine bay here before, so I'm sure it's going to help for IATs. But we got to deal with flow too, so we'll see how it goes. All right, it's dyno day in the rain. I've got a couple things I want to prove today, or try to get some data on at least. So I've got methanol injection set up, and I have octane booster on hand, and I have this ram air intake to test. Does the ram air intake, with its plumbing and diameters, lose power, stationary, over an open throttle body? And if it doesn't, that's pretty amazing. I'm going to throw a fan in front of it just to see if I can add a little bit of air pressure to it if it's sensitive to it. And then the next thing I want to prove is just how much does this guy want methanol to work? And then we will add some octane to it to see how much power this combo can make. Yeah, so I checked the logs. We're at knock threshold, so knock sensor's active. We're seeing that here. If you watch the blue line, which was the hotter run, the actual dips are timing pull, and then it pulls out at the end to the 15 degrees of timing. This dip in here is like 12, and then try it again. And then, so we're basically up against knock. This is fresh, but 91 octane. So we can't really get 15 degrees in it until the higher RPM. In the mid-range, we're stuck with 12 degrees, 14 degrees peak, and then pulls back again. So that's a fair baseline. Let's see what we can do now with some methanol. So we have our first run with methanol on. You can see we did really good in the mid-range, and the top end fell off. We got to hold the 15 degrees of timing all the way through the mid-range. The top was too rich for closed loop correction to fix. It was maxed out at 20% negative the whole time, which is my limit. So I'm going to adjust my fuel table now to take some fuel out. I actually have a conditional fuel table that will be used to reduce fuel only when methanol is active. Okay, so we're still rich, but only 14%, so it's within the range of wideband correction. We added 3 degrees of timing in the mid-range and 4 up top. And the, well, it liked it, you might say. We have no knock at all yet. So with 4 degrees more timing and a number 6 methanol nozzle, which is like 625 milliliters per minute, injecting pre-blower, we kind of picked up 80 horsepower and a bunch of mid-range torque. So some blowers really like this stuff. Let's see what that top end dip's about. Wonder what the cam timing's doing up there. Maybe it's just all done. These edelbock blowers have a lot of runner length, so they probably aren't going to do much past 7,000. Peak power is at 69. Seems like it wants to party. You're going to feel that torque. Loves the timing. All right, so that's another 2 degrees of timing for a total of 21 degrees of timing. It's really responding to it still, and there's no knock. We're still on 91 octane. The tank fuel is exactly the same fuel that was struggling. You see it in the blue line there. Knock was present, and we were limited by knock. When I drove in and we enabled meth, and not even a monster kit, this is not that big of a flow with the number 6 nozzle for this power level. And it it's really enjoying methanol. We're at 13.5 pounds of boost, and it's just smoothens the curve, timing's bang on, and it just loves it. I did a little bit of cam timing change at the very top end there. I think it held on a little longer, a little less of an obvious dip there, but it's still there. And that was a 4-degree sweep in cam timing from 68 to 75, which you can see that should have affected that more. So it barely affected it, but it's kind of out of gas there, which is kind of expected on a 13-inch runner on the edelbock system. So I don't know if I should throw more at it or not. I mean, that 2 degrees of timing still picked up, 32, 30-ish horsepower. So 21's already a lot. I have a smaller pulley. I'm already overdriving the blower. I'm near the peak rotor RPM. We have only a 6-rib belt, really good wrap, but only a 6-rib belt. We have a 20% over crank pulley, and we have a 3 1/4 on the top. I have a 3-inch. I just don't know if it's gonna. Last time I tried it, it slipped. So more boost or more timing? Maybe not more boost. I already had the 3-inch on there. I went to go grab my 3, and I realized I had a 3 1/4. So that means the 3 is already on there. So that's it. So we're ready. I think it's like 19,500 RPM at peak, and blower is rated for 18. Real world says 20,000. So probably out of steam there. Pretty amazed that worked out. So that fall off on the top is probably just the blower running out of gas. It goes from 13.5 to 13.4 PSI at the very, very, very finish line, like at 7,500 RPM. So I think the blower is all used up. That's all she's got. So I guess I can do a little testing here to see. I'm pretty sure that this cold air intake is not holding it back, but I should open it up and see what it does with open throttle to see if any of this thing is holding it back. But the numbers it's making, I don't think it is. So a little more timing. Maybe we'll play with the intake a bit. But yeah, some days it comes easy. Well, 2 degrees more timing barely made a difference, and just up top, which fixed that drop off. So I'm going to leave a little more timing at the top, but the rest of it's definitely not worth it for the extra cylinder pressure. Probably, if I want a dyno better, I'll get rid of the radial or the drag radial in the back. But I mean, it is 100% humidity outside, pouring rain, but it's nice and cool. So I'm starting the runs at 80 degrees Fahrenheit, or 80, well, more high, 88, 87 degrees manifold air temperature at the back of the blower, and finishing about 125. So, and it was doing about 20 degrees higher than that at the end of the run without the methanol. But the octane improvement is just ridiculous. So our peak power RPM moved up. So the timing up top is a good idea. I'm going to leave that in there. It seems to like it. When things are starting to pile up, it can carry it further. But now it's time to shape the curve a bit, pull some of that mid-range out. That cylinder pressure is no good even without knock. We don't need the extra cylinder pressure. It's not helping. So we added 8 degrees of timing with the same fuel, and basically picked up 100 horsepower. So pretty good day for methanol injection. My next step is to use a pressure feedback sensor to help the system build safeties so we don't blow this thing up when the methanol sneezes, because we need it now. Now we're meth addicts. This car is. So anyways, I think that was a successful day. I'm going to try a little bit of ducting dyno here and see what it likes, and go from there. Well, I couldn't remove the whole intake because the methanol nozzle is on the tube here, but this tube's a pretty good shot. From the 5-inch right out to the 90 mil throttle body, I think that BBK thing is, which is tiny, but I already had to port this blower just to fit that one, because the blower entrance, because it was just made for a stock 80 mil. So in spite of the fact that it looks like it should be smooth sailing in there, pretty big can, I think it might be hurting me. So our repeating 714 pretty easy, and I opened it up and we went 743. So what does that say? There's one more thing I want to try. I've got the crankcase ventilation system going back into the intake. I don't know how much oxygen that's stealing, but I'm going to connect this back up, disconnect the crank vent, leave it open, and see what it does. It's hard to believe a can that big, with everything being at least 6 inches in diameter, all the way down to there. I mean, I know we're stationary, but I don't want to have to make up for losses with ram air effect. I need to start at a neutral. So, yeah. We might have to do this piece by piece and figure out which part is the restrictor. We'll do crankcase ventilation first. And then I think we'll do maybe the air filter by itself on the end of this can after that. Yeah, okay, so the crankcase ventilation matters, about 10 horsepower worth, but we can see the carryout on the top. That open element on the air filter, or the open tube, no air filter, still just moves more air. So I've got to find out what part of that intake tract now is restricting it. Is it the scoop in the bumper? Is it the corrugated 6-inch pipe? Or is it the area where it passes through the fender? Or is it the actual cone filter itself? More questions. So looking at the logs, we've lost about 0.8 to 0.9 of a pound of boost with this configuration versus the open tube. So It does pick up a bit by not having that in there, but at the end of the day, this airflow is limited, so I got to figure that out. Well, let's see what this configuration does. Obviously, it's one short piece of pipe and a air filter difference. Seems like it's a big enough air filter. It shouldn't be a restriction, but who knows? Well, it's pretty safe to say it's not the air filter, because in that configuration, it just carried it forever like this. So that means my ram air system somewhere down here, probably right where it goes through the inner fender, because the hole in the inner fender is somewhere around here, and it's the smallest part, so I might have to hack a bigger hole in the inner fender to make this work. Or maybe leave that area open. I'm wondering, underhood deflector style. Maybe gonna have to try putting it back together and sticking a fan on it. I don't know. Fan is just not gonna have enough airflow to simulate even close to road. But if it's restricting that badly, I can't see air pressure from the road fixing it. So that is a good number, and it just carries out the top like a champ. Blowers just love no restriction on inlet. And this is 14.1 psi boost, pretty much 1 whole pound more boost than the that runs under it there. So yeah. So I disconnected this to see if it was this funnel connection, because it's a big old 6-inch, but it has a bad cross section. It should be longer and kind of flowed together. Can't really see much in there. There we go. But it made no difference. So I think it's all about the fender pass-through point. Well, learned a few things today, and due to having Holly and a speed density style tuning, I can do whatever I want with the intake track with no MAF sensor. I can open the PCV system with no faults. But I found 10 horsepower loss in a closed PCV system. There's no oil right now in that pipe. It's just fumes. So those fumes are taking the place of a little bit of oxygen, and so they lose some horsepower. So probably should have an open cannon for the track. And then I learned that this pipe is great, but this connections with the fender is a problem. It's probably passed through the fender spot because it's too close to the air filter cone. It's kind of trying to make the air filter cone into a double pass filter. Has to go through it and then back out of it again. So I'm going to have to cut a bigger hole in the fender and redesign that. And then I learned that this thing loves methanol. I did not get any noticeable detonation up to 750 horse on 91 octane pump gas with methanol. Cool day. Like, this is not, I'm going to have more octane on race day, but it was happy. And that was IATs. I would try to start in the 80s, and they would end around the 120s. And they were definitely higher without the methanol. On the finish, the start was the same. So yeah, the combo was performing well. I pretty much think I've maxed out what it can do, and now I need to make it all good on the track. So, but it seems pretty solid. I need to rig up some methanol safety solutions. I'll probably make a video on that. And I think it'll be good. It's not broken, runs great, makes tons of power. It's going to be a riot. All right, so this is the air box out of the fender, version 5 or 6 or whatever. This big, huge elbow part of the filter case. This is the piece that was there before. Last dyno that lost like 25 horsepower if it was hooked to the fender. So the inner diameter of this has been changed a bunch, so more sheet metal has to be cut out. But I'm gonna dyno it this way first and see if it loses any power. Okay, we've been beating on this poor thing, but the cliff notes is we have with the air box all in the car, and as soon as we hook up the accordion hose and the scoop, we seem to drop about 4 horsepower. So that's the difference from here to here. This was almost a hot lap to see how stable it was. And these were with the whole air box out of the car. Colder. And then the hero move was this one here, but that was cold blower, first pull of the day. And this one was second pull, but then we got an actual stable number going here to work with. So this is airbox out of the car, but no accordion hose and no under bumper scoop. And it seemed to be that 4 horsepower there, 4 or 5, is the under bumper scoop loss. I'm going to redesign the scoop a little bit, get a little more airflow through it. But the more we add, we're just going to lose a little bit until we start getting some airflow in front of it, like car movement. So I think we're almost at the point where it's developed as far as it can be on the dyno, and now I need to unhook it and hook it up at the racetrack and see what the mile per hour does. But overall, we got lots of air volume available for it. I think it will work.